Kind of want to do an example, but I don't really have one prepared. So I'm just going to make one up. Sure, something like this. Looks really messy, and if you did it from left to right, you'd get the wrong answer. So let's follow the order of operations. So we want to do the parentheses first. So we're not going to do anything else other than what's inside these parentheses here. With a longer problem, even problems longer than this, it's going to look very tedious. It's going to be very repetitive and monotonous. And you're going to want to skip steps, or you're going to want to do something to shorten it. And I understand. I used to do that. I used to skip steps because I thought I was cool. When you skip steps, your likelihood of getting the wrong answer in the end skyrockets because you either completely skip a step, like you forget to do it, like you'll say, okay, I'll do this later, and then later comes, and then you don't remember to do it. Or you do a step out of order, and then when the time comes, you do that step again. Do every step on a new line. So this is 4 plus 2. Remember, this on the outside, this number on the outside of this parentheses is the same thing as multiplication. But now we'll have two constants next to each other, so I am going to put the little dot next to it to signify that this is multiplication. And then that 3, this 5 minus 2 becomes the 3, but that exponent hasn't done anything yet. So we're going to leave that there, and then minus 5 squared. So we're going to do all of the exponents at the same time as we come across them. Everything else leaves themselves alone. So we haven't resolved this multiplication yet because we still need to do this exponent. Now, if you're not sure what a number is when you're trying to do an operation, there's no shame in whipping out a calculator. 3 to the third power is, remember, do a little side note over here, remember 3 to the third, no, that's pretty dark. 3 to the third power is the same thing as 3 times 3 times 3. Remember, we're doing the base multiplied by itself this many times. So 3 times 3 times 3, and that is 27. So that's the number that I'm going to replace 3 cubed with. So now this is 2 times 27. Now if you were to do this multiplication here first, like out of order, you do 2 times 3, and then you'd have 6 cubed. You'd still need to resolve the exponent, but 6 cubed is 216. So that's not going to be the right answer. That's not where this is going to go. Subtraction, haven't done that yet. Okay, so now we have 5 squared. So here's the question. Are we squaring 5 or negative 5? Because remember, I said we can take any subtraction and turn it to a plus and negative, but we haven't resolved all of the exponents, so we're not doing anything with the subtractions yet. So we're going to leave the subtraction alone because this exponent only wants to see what is under it. Like this exponent did not want to see this 2 because this multiplication is too far away on the order of operations to see anything else other than what's inside these parentheses, which is this 3. Same thing here. This exponent is so far away from addition here, the addition and subtraction thing. So this definitely doesn't want to look at anything that this has to do. So 5 squared is 25. We've done all of the exponents. Now let's do the multiplication. And there's only one. So we got, again, haven't done anything with this 4 or this plus. 2 times 27 is going to be 54 minus 25. Now, if we have all additions and subtractions left over like this, we do these in a row. So we don't really get to pick and choose which one we do first. We just go from left to right. So 4 plus 54 is 58 minus 25. And then 58 minus 25 is going to be 33. Yes. Cool, and then that's our answer. I know it's rewriting a bunch of stuff over and over again, and with bigger problems it's going to look even more daunting just to do one problem. But this is the most surefire, guaranteed way to always do the order of operations properly. I can't recommend doing it this way enough.